Hello everyone, welcome to CivilPrep. This is MentorCase, a geography optional initiative for 1000 case studies. So this is one of the case where we'll be seeing that certain aspects on the Arctic pollution. Okay, here we have certain topics for today's case study, that is wetland restoration at Asan. Okay, we'll be looking at its location, where it is, and what initiative has been taken. Then hailstorm patterns in the Himalayas. Okay, where we are seeing that there are certain climate anomalies in the contemporary time. Then monsoon behavior and hail. Then we have weather forecasting advances, that is 12-kilometer probabilistic model. Then Arctic haze impact on South Asia. Women in Panchayat and environment, that is ground up governance linkages. So guys, to join our YouTube channel, you can scan on this QR code, and to join our Telegram group to have answer writing practice, to ask questions, to ask doubt, you can join this, join through this Telegram QR code. Okay. Now, moving to our first topic, that is the wetland restoration initiative like Asan Conservation Reserve. Now, if you will see closely in the map of India, we have Uttarakhand. Under this Uttarakhand, we have Dehradun district. Under this Dehradun district, we will see that here we have Asan Conservation Reserve. Okay, so this is Asan Barrage and also the Asan Conservation Reserve. So recently what happened in Uttarakhand, there are various issues with respect to biodiversity, flood control, and climate resilience. These issues were seen. Now, for this, there was a single solution was taken. And this solution was wetland conservation. Now, here we'll be seeing that Asan Conservation Reserve, it is present in Uttarakhand, spanning almost 444 hectares, consisting of almost 118 lakes. So we can see that how diverse this region is, how rich it is in the habitat and species diversity. So here we'll be seeing that when we'll talk about the biodiversity, the biodiversity recovery is going on with over 330 bird species, almost 49 fish species, okay, which are thriving in this particular region. Apart from this, there is also ecological improvement. Where almost more than 20% of improvement has been observed because of the restoration practices. When we look at this part here, we can see that this region, it can be treated very well with respect to the Ramsar Convention. Okay, here we'll be also seeing that there is a conservation principle which can be applied of Aldo Leopold, where he has said that the conservation of the region, it can be done very well by the environmental principles. Okay, but we need to see certain real world solution also. The first thing we need here, that is the community-led monitoring and ecotourism. Here we'll be seeing that in the Asan, the initiative boosted ecotourism and its revenues by almost 25%, and the water quality, it improved here. Water quality improved almost by 20%. So this is the first case study of Asan wetland, okay, where the wetland restoration practices are being taking place in the contemporary time. Now, as we move to the next case study, here we have the hailstorm patterns in the Himalayas, that is a climate anomalies which is documented in contemporary time. Now, what is seen in the Himalayan region? As we know, okay, this is the Western Himalayas and this is the Eastern Himalayas. In the contemporary time, that is in the year of 2025, it was seen that the hailstorm, it has risen by almost 30%, okay, and this is happening because of the sudden drop in temperature, okay, sudden drop in temperature, which is almost taking around 8 degrees Celsius. For example, if there is 10 degrees Celsius is temperature, so it is dropping to around 2 degrees Celsius. So this is the event which is taking place frequently in the region of Himalayas. So because of this, what we are seeing that there is a large scale disruption of agricultural crops. Okay. Apart from this, it is also resulting into the various infrastructure losses. Now, let's understand about the formation of hail. For example, this is a region, and here we see that there is formation of clouds or thunderstorm. So in this region, what we will see that there is a condition of updraft. Here, the updraft, it will be quite warm. Okay, this is a warm updraft. And what will happen here? Whatever the moisture which is present in this region, it will be getting converted, it will be going up along with this updraft and it will be forming moisture. So what we'll see here that there is a freezing point. As this updraft, it moves beyond the freezing point, or I will not say this as freezing point. Let's call it as dew point. Okay, as it crosses the dew point, it starts forming the particles. Okay, and what will happen in this region? This will result into the formation of rain droplets. The droplets will be formed, but we will see here that as these clouds they become more bigger because the updraft here it is quite strong. The updraft is quite stronger here. So whatever the rainfall is occurring in this region, whatever the rainfall is occurring, this rainfall it is taken back by this updraft and the water it is moving to the greater heights. After certain duration of time, it will pass on the freezing point. As it passes the freezing point, it starts to accumulate, and this results into the formation of larger hails. Okay, now these hails are formed now, but they are still taken up in the upper air atmosphere by the updraft. Now, what will happen here as the updraft has formed? So, because of the cooling condition, there will be formation of downdraft also. Okay, because of the formation of downdraft, the hails, as the pressure will decline in the region, the hails will start to come down. These hills, they will try to come down in the region where the downdraft has formed. So this will result into the hailstorm. Okay, so through this condition, we can see that there is formation of hailstorm. Okay, so we can also look at this particular aspect by the Perkins process of raindrop formation. Okay, so in this way, we can see here that how this particular condition is resulting into the formation of this hailstorm. Now, let's apply this in the Himalayan regions. So we will see here that in the Himalayan region, the Tarai belt, it is around 300 meters, while the Mahabharat Lake, it is around 2500 meters. And the low mountains, they are almost 400 to 2400 meters in height, while the middle mountains, they are 100 to 1000 to 4000 to 400 meters in height. While the high mountains, they are ranging between 3500 to 8880 meters. So therefore, we see that these regions, they are very much vulnerable for hailstones. Okay, so here we'll be seeing that not only the region of Western Himalayas, but also of the region of the Eastern Himalayas is witnessing such hailstorm conditions in the contemporary time. And here it is exacerbated by the climate change effect. Now, how climate change is impacting this formation of hailstorms? Number one, there is global warming. So because of global warming, there is increased evaporation. Because of increased evaporation, there is high moisture content in air. Because of the high moisture content in air, the updraft, it is becoming stronger, resulting into the increased hailstorms, basically in the Himalayan region. Okay, so here we can also look at this altitudinal variation. Here we can see this altitudinal variation. This altitudinal variation, it is explained very well in the altitudinal zonation model, which is provided by Humboldt. Okay, Humboldt has provided this model here. Now, when we look at the real world solutions, when we look at the real world solutions, there has been a early warning system. And number two, adaptive agriculture. So under this early warning system, we'll be seeing that Himachal Pradesh, it has decreased crop damage by almost 25%. Okay. Here basically there is installation of hail nets and revised crop calendars. So because of this, they are able to decrease whatever the hails are impacting the agricultural crop and the region. So this was the case study of this region, that is the hailstorms in the region of Himalayas. Okay. Now, next case here we have with respect to weather forecasting advances, that is 12-kilometer probabilistic model by IITM. IITM, it is basically present in Pune. Now, what is a probabilistic model? For example, I want to search for something that I am trying to do a experiment, okay, which is a part of a positivistic positivistic philosophy of geography. Okay, so here I'll be taking various samples in a particular space. Okay, that event A has occurred, event B has occurred, event C has occurred, and event D has occurred. So on the basis of these events and on the basis of the probable sample space, I will be able to create a set of outcomes. So on the basis of this set of outcomes, I will be able to design that what is the probability of a particular event in a certain space. So this is a probabilistic model, and the weather forecasting, which is being experimented by IITM, it has been done over the 12 kilometers range. So this was the range, this was the area where this experiment has been conducted, and they have found something quite unique. So what they did here, they took real-time Doppler, real-time Doppler radar, and they use certain advanced algorithms, okay, which was able to form a model. This model, it was basically predicting unprecedented, precise, extreme weather events. Now, this is something unique which has been done by this probabilistic model. Okay, because we will see here that majority of the radars or Dopplers which are present in different regions of not only India but of the world, they have very low accuracy. Some have 30%, 40%, or 50%. But here we have an accuracy of almost 90% for the prediction of extreme events, which was more localized in nature. Okay, so here we see that this is one of the important model which is applied in the contemporary time, and we can take this model to a atmospheric dynamic and chaos theory. which provides the behavior of weather systems. Okay, the chaos theory, if we look at, it was introduced by Lawrence in the field of meteorology. Okay, and here this probabilistic forecasting model, it is one of the tool of quantitative revolution, a part of a systems analysis, okay, which is used to study the spatial variance. Okay, so this is part of this probabilistic model. So we can see certain real world solutions. So it can be used for the flood risk management. Okay, the deployment of such kind of system has been done in Maharashtra, basically to improve the early warning system. So because of this flood risk management in the region of Maharashtra, we will see that there is almost 30% reduction due to the flood damages. Okay, so this is one of the important part which is helping us to understand the weather forecasting in a better manner by using this probabilistic model in the geographical area. Okay, now next topic here we have with respect to Arctic haze and its impact on South Asia. Now, what is a haze? This is the first question. Now, if we look at clouds or if we look at certain region, so here we'll be seeing that there is presence of certain amount of aerosols. Okay, there will be presence of SO2, NO2, CO, CO2, Hg, lead, Pb lead, Hg mercury, then certain other ions, okay, PM10, PM 2.5 particles. So this aerosol is present in certain regions. So what happens? These aerosols, they act as a hygroscopic nuclei. Okay, they act as a hygroscopic nuclei where there is formation of water particles are getting deposited around this hygroscopic nuclei. But what will happen here when such kind of particles they will increase in the atmosphere? When they will increase, so this will actually result into the formation of dense clouds. Okay, the clouds they will become very dense, and because of the dense nature, they will become opaque. Okay, when they become opaque, here what happens? As the sunlight will come here in any particular region, for example, this is the insolation. So this insolation, after striking, it is becoming terrestrial radiation. So this terrestrial radiation, it will be reflected back by the this opaque cloud. Okay, so because of this, what will happen? there will be increase in the thermal energy in the system. There will be increase in the thermal energy in the system, which will basically act as a positive feedback mechanism with respect to formation of more clouds, then more pollution, and more heating. Now, under these circumstances, what we will see that this may result into the formation of such kind of pollution too. Now, what is happening in the recent time? These Arctic haze, these Arctic haze, they are formed in the region of Arctic region, and from this Arctic region, where particularly there is certain contaminants, they are resulting into the increase in pollutants. Okay, as we have seen earlier, like SO2, NO2, carbon monoxide, carbon dioxide, mercury, lead, PM10, PM2.5. So they are accumulated in the Arctic region. As they are accumulated in the Arctic region, they are resulting into the formation of very large number of haze. Now, what happens next? These haze, okay, these haze, they are moving over the regions. Okay, here we can see that there are jet stream presence. Okay, this is one of the jet stream. This is a subtropical jet stream, and this is a another polar jet stream. And this is subtropical westerly jet stream. So what will happen here? As there is convergence is taking place over the upper air atmosphere, and there is sinking motion is taking place because here there is formation of high pressure system. So because of this, the system here will be seeing that they will be out moving. There will be out moving of this haze. There will be outmoving of haze in the various tropical and subtropical countries or tropical regions. So the same phenomena has happened in the region of South Asia, where the Arctic haze has moved to the region of South Asia, that is the region of China, India, Malaysia, Indonesia. Now, let's look at the impact. The impact basically here is it is resulting into the air pollution, which is getting more severe. Okay, the air pollution is getting more severe, and also the haze. Okay, it is increasing heat in terms of global warming because of the formation of more clouds, which are opaque in nature. Okay, so overall, we'll be seeing that the weather conditions, the health of the people, it is getting impacted because of such conditions here. Okay, so it is seen that in 2025 pre-monsoon region, it saw a 15 to 20% rise in airborne particulate matter levels across the northern region of India. 20% increase in northern India. So this is the basic data which we see, which has also impacted Indian region. Okay. So here we see that this can be seen from the atmospheric dispersion model, where the analysis is done on the long range transport of pollutants, basically because of the jet streams and the atmospheric conditions, that is the high pressure system and the convergence of air at the higher atmosphere and the divergence of air at the lower atmosphere, resulting into the movement of the pollutants and haze towards the region of South Asia. Okay, so here we'll be also seeing that there is certain environmental flow theories can also be seen, evaluating how changes in jet stream patterns it affects the regular air quality. So here we can see the polar jet stream, also the uh, subtropical westerly jet stream, which is impacting the region here. Okay. So when we look at the real world solution, in Delhi region, the proactive advisories improved the air quality index by 12 points, reducing severe haze impacts by 15%. So this data source set is taken from municipal air quality reports. Okay. So the example is of New Delhi, where the air quality index, it is improved by 12 points due to proactive measures, because it is also one of the region of northern India where the haze have been formed. Okay, so this is one of the case with respect to the haze in the Arctic region and how it is impacting the region of South Asia. Now, moving to the next case, the women in panchayats and environment ground up governance linkages. Now, what we will see here that in India, what we'll be seeing that here the representation of women, it is less than 33 percentage in almost parliament and all the state legislative assembly. It is less than 33%. So this is one of the issue which is being seen with respect to the representation of women. So here we'll be seeing that we have certain feminist geographers, okay, who has highlighted in the previous era about the feminism or the role of feminism in the development of the modern society. So the number one feminist geographer here we have Doreen Massey. Doreen Massey has said that the space is socially constructed. Okay. Apart from this, it is dynamic and embedded with the power relation, including gender. She also introduced the concept of power geometry. You can write this point, arguing that the mobility and access to space is unequally distributed. She also says that often the prevailing man in the capitalistic and globalized system has done this part. Okay, so she is basically providing She is alleging that the capitalist has resulted into such kind of system in the globalized world. Here we have another geographer. Okay, here we have another geographer, that is Gillian Rose. Gillian Rose critic the hegemonic masculinities in the geographical knowledge production and argued that the traditional geography excluded. It excluded the women's experiences and subjectivities. So this is one of the very important point which is given by Gillian Rose. She also emphasized the visual culture, identity, and positionality, showing how gendered bodies interact with space differently. Interacted with space differently. So here, this is one of the problems which was highlighted from the perspective of Gillian Rose and the Doreen Massey. So here the same thing is seen from the perspective of India also, where we see that in the contemporary time, there is, if we talk about the parliament and the state legislative assembly, there is less than 33% of representation by women. But if we look at the panchayat system, here, over 46% of the seats of the panchayat, it is occupied by women in India. And the highest share will be seeing that it is present in Jharkhand. Okay, so this is one of the part which is helping the empowerment of women. Define the special relation of men and the masculinity with respect to the power and the power geometrics here. So therefore, we see that this gives us a very good perspective for the development of the power solution in India. Okay. So here, if we look at another case study, or we can look at the real world solution, we can see it in the Rajasthan, where the women, they saw increased local energy, local energy access almost by 30% and reduced waste generation almost by 25%. Along with this, boosting the district's overall sustainability. by almost 20%. So all these things we see that this has happened because of the empowerment of women, or the region where the women were in power in the Rajasthan region here. So this we see as one of the case study which is important, which is resulting in the development of the regions in India. Okay, so this initiative will be seen that it was seen under the Haryali Green Villages. Okay, it is seen under the Haryali Green Villages, which is providing us a sustainable solution in the contemporary time. So guys, these were certain case studies. So if you like the case studies, you can join our YouTube channel, and also you can join our Telegram group for the discussion of question and answers. Okay, so here we'll be interacting. So this is the mentor case program, geography optional. That is 1000 case studies will be covered in a particular year. So guys, see you in the next session. All the best and take care. And yes, do like, share, subscribe, and comment that how did you like this video and what were the good part that you learned here. Okay, so see you tomorrow.